Now, to calculate VR, you need to identify where VR is. VR is from here up to there. Okay? Now, I'm sure you can agree with me that VR and SR, they are on the same side, okay, of triangle TSR. And VW is parallel to ST. Therefore, I can apply the proportion theorem in triangle TSR. Yeah, sometimes geometry requires you to see the diagram more clearly. Okay, it's not difficult. It's not difficult. Geometry is not difficult. I refuse to say that. It's not difficult. Okay? So I've identified triangle TSR and I'm going to apply the proportion theorem in order for me to calculate the length of VR. And it's going to be easy. So I'll show you now how easy it's going to be. So first I identified my triangle TSR. Okay? That's the first thing. Now be aware that as well that since we know the length of TW in terms of Y, the length of WR in terms of Y, it means I can use the coefficients of Y here to determine the lengths of SV and VR in terms of a third constant. Some of you are not paying attention. If I ask you now to repeat what I just said, you probably won't be able to repeat it. Okay? Since we know the length of TW and WR in terms of Y, we can use those constants. Okay? So that is, we can use the coefficients of Y here to determine the lengths of VR and SV in terms of a new constant. I hope you are aware at this stage, based on everything I've done from the beginning, that if we can apply the proportion theorem in triangle TSR, it means that TW divided by WR is equal to SV divided by VR. You agree with me then? Now, if that's the case, then it means we can use another constant which is different from K and Y. In this case, I chose N. In fact, N was proposed by one of the learners in the other class. Okay? Yes, so sometimes I ask learners, choose which letter you want to use. Someone chose N. Okay? So what that means is that the length of VR in terms of our constant N is going to be 7N. For SV, it's going to be 2N. You don't use the same constant, okay, for all sides or for different sides of a triangle. You have to use different constants. Right? Are you following that? Is it making sense? Okay, some of you are quiet. Alright, so I'm going to apply the proportion theorem. Now, allow me to also tell you that you can use one of the four corollaries. Remember, when I did the proof of the proportion theorem, I told you about the four corollaries which can originate from the original proof. So, VR, okay, if I want to calculate VR, there are many ways of calculating VR. Okay, so allow me to calculate it as this is RV, or I can say VR over VS. Okay, so I'll say VR, so VR over VS is equal to, I'm going to use the proportion theorem, so it will be WR over TW. So this is WR over TW. Then my reason is the proportion theorem, which I prefer to write as line parallel to one side of triangle. Okay? If you like to write proportion theorem, then you must also state the lines that are parallel. Alright? Then let's substitute now. So VR over VS. Now what is VS? VS in terms of N is 2N. That's the length. So I'll put what? 2N. Right? Okay? And then if I want to calculate, remember also here, okay, well, we have got exact values here, so it will be better for me in this case. Let me change that ratio because this won't work. Let me change that ratio. Please allow me to change this ratio here. I'm going to use one of the corollaries because as it is, it won't come out well. Alright, let me change this. Let me change that. Okay, please make sure you pay attention because I'm going to rewrite it. So what we can do to calculate VR, since we are given SR, remember we are given what? SR. So we can say, since SR is given as 36, so I can say VR over SR. I'm going to repeat that. Okay, so I can say VR over SR. Okay, why am I doing that? Because I'm given the length of SR as what? 36. Okay, so I'll write that down. So it will be VR over SR. Please, it's still the proportion theorem. That's the reason. Right? Then, on the other side, the good thing is I've got my length in terms of y. So it's going to be, in this case, it's going to be WR over TR. You following them? Yeah, if you understand this, you won't have any problem. Okay. Right? So I'm going to write that down. So here it's going to be WR over TR. Now we can start smiling. Right? VR over 36 because we are given what? We are given SR. And what is WR? It's equal to 7y. Right? So I put 7y there. And TR is equal to 2y plus 7y, which is what? 9y. Okay? So I'll put 9y. Then, do not stress this y and that y are going to cancel out. So in the end, if I want to calculate my VR, it's going to be equal to 7 times 36 over 9, which will give me 28 centimeters. Right? I hope you are following. Are you following? Huh? Then, but you have got a question. Okay. Can I move on? Okay. Please, I hope you can see what I'm doing. Now, let's move on to the last question on question 2. Right, the last question is this one here. Now, I still need the information that I had, so let me put it. So here, I had 5K, then this was 7K, and that's 2K. Then here I have 5Y, that's 2Y, this is 7Y, that's 7N, this is 2N. Okay, I'm putting that because I still need that information. Right? Now, the question here says, determine, okay, this is a ratio. Area of PSR divided by the area of WVR. So, if I go to my diagram, PSR is P, that's S, this is R. Okay? Do you see that? Right? Then, WVR, let me use a different color. Maybe this one will be better. Right? WVR, so we put W, V, and R. Okay, now, what do you notice about those two triangles? They share a common vertex, right? Which means they also share a common what? Angle. Do they have the same height? Okay, remember this is triangle WVR. Okay, and the big one, which is going to be that one there, that's PSR. Do they have a common height? No. So which concept can you use? Based on what I told you yesterday. If they don't have the same height but they have a common angle, how would you calculate this ratio? Use the area rule. Thank you, Aman. So, because they have a common angle but they don't share a common height, we are going to use the area rule. Okay? So, we'll say area of triangle PSR, okay, is going to be equal to half times. Now here our angle is this one. That's the common angle. Angle what? Angle R. So it means that I can write the area as PR, okay? PR times what? SR times sine R. That's the area rule. So I want to calculate the area of PSR based on the information on the diagram. That's how I would carry on. Then the area of triangle WVR, okay, is going to be equal to what? It's going to be half, okay? It's going to be half WR, half times WR times VR, right? Times sine R. Okay, I'm sure you can see that some of the terms will cancel out. This cancels with that. This half cancels with that. Okay? Can you pay attention? Okay? Then from here now, well, let me go to the top. So from here, we move on to the top because of space issues. So from there now, I can now substitute and say the area, this can be simplified. What is PR? PR in terms of y, okay, is going to be 5y plus 2y plus 7y, which is what? 14y, right? Times. Then SR is going to be 2n times 7n, which gives you what? Which gives you what? 9n, right? All over. WR is 7y. Okay? And then VR is 7n. Are you following? Right? Now, this becomes interesting. I'm sure you can say this cancels with that cancels with that cancels. Right? Then 7 into 14, that's a 2. So get it up heavy. Our final answer, okay, let me write it in red. It's going to be 18 over 7. That will be our final answer. So the ratio of PSR over WVR is going to be 18 is to 7. And I'm sure you can agree with me that triangle PSR is greater than WVR. Okay? So this will be your answer.